This video is about finding the value of sine and cosine at special angles. This is AP Precalculus Topic 3.3. If you appreciate this content, please give it a like. So actually, half the battle is memorizing the chart that's on the screen right now. So pause the screen if you need to, copy this down, and study it. At the beginning of your next quiz or test, I want you to ask your teacher for a piece of scratch paper and write this chart from memory on the scratch paper, and then use it for the quiz or test. Eventually, I want you to know this so well that you don't even have to write it down. It's all in your head. Number 1. The sine of 5 pi over 3 is the same as the sine of pi over 3, which is radical 3 over 2. Except that the sine of 5 pi over 3 might be negative. Here's a unit circle, a circle with radius 1. On the unit circle, sine is a y value and cosine is the x value. Whether this is positive or negative depends on what quadrant 5 pi over 3 lands in. We have memorized that pi is right here. However, since we have a denominator of 3, let's think of pi as 3 pi over 3. 2 pi will be 6 pi over 3. 5 pi over 3 will be one multiple before 6 pi over 3. That puts 5 pi over 3 right here in the fourth quadrant. Y values are negative in the fourth quadrant. So the value of the sine of 5 pi over 3 will be negative radical 3 over 2. Number 2, the cosine of 3 pi over 4 will be the same as the cosine of pi over 4, which is radical 2 over 2. Except it might be negative, depending on the quadrant. Here's my unit circle again. We know that pi is right here. Since we have a denominator of 4, let's think of pi as 4 pi over 4. Therefore, 3 pi over 4 will be one multiple before this. That means 3 pi over 4 will be right here in the second quadrant. Cosine is the x value on the unit circle. In quadrant 2, x values are negative because we are to the left of the y-axis. Therefore, the answer is negative radical 2 over 2. Number 3, the sine of 5 pi over 6 is the same as the sine of pi over 6, which is 1/2. Except maybe it's negative, depending on the quadrant. Pi is right here. Since we have a denominator of 6, let's think of this as 6 pi over 6. Therefore, 5 pi over 6 will be one multiple before 6 pi over 6. That puts it right here in the second quadrant. On the unit circle, sine is the y value. Y values are positive in the second quadrant. We are above the x-axis here. Therefore, the answer is positive 1/2. Number 4, cosine of pi over 6 is right on the chart. It's radical 3 over 2. And that's it. Number 5, the sine of 11 pi over 6 will be the same as the sine of pi over 6, which is 1/2. Except it might be negative depending on the quadrant. We know that pi is right here. Since we have a denominator of 6, let's think of this as 6 pi over 6. 2 pi, which is on the right-hand side, we can think of as 12 pi over 6. Therefore, we can see that 11 pi over 6 will be one multiple before 12 pi over 6. That puts it right here in the fourth quadrant. Sine is the y value on the unit circle, and y values are negative in the fourth quadrant. So the answer is negative 1/2. The cosine of 2 pi over 3 will be the same as the cosine of pi over 3, which is 1/2. Except it might be negative depending on the quadrant. Pi is right here. Since we have a denominator of 3, let's think of this as 3 pi over 3. 2 pi over 3 will be one multiple before 3 pi over 3. So 2 pi over 3 will be right here in the second quadrant. Cosine is the x value on the unit circle, and x values are negative in the second quadrant, so the answer is negative 1/2. Number 7, the sine of pi over 4 is right here on the chart. It is radical 2 over 2, or you could put 1 over radical 2. Make sure you know that both of these are the same. So we have radical 2 over 2, and that's it. Number 8, the cosine of 3 pi over 2. Notice that pi over 2 is not on this chart. That's because pi over 2 is right on the y-axis. Pi over 2 is the angle formerly known as 90 degrees. So pi over 2 is right here. 3 pi over 2 is a multiple of this. So right here at the top is 1 pi over 2. Pi is 2 pi over 2. And then 3 pi over 2 is down at the bottom. So this is the 3 pi over 2 position. We can evaluate problems like this using coordinates. Remember, I have drawn the unit circle. That means that the radius is 1. So what are the coordinates of this point? The x-coordinate is 0 because it's right on the y-axis. The y-coordinate is -1 because it is down by the radius of 1. So this is the point 0, -1. On the unit circle, sine is the y value, but cosine is the x value. The x value is 0, so the cosine of 3 pi over 2 is 0. Number 9, the sine of pi. We know that pi is right here. This is right on the line, so we will use coordinates. The x-coordinate is -1 because the radius is 1, and we are to the left by 1. The y-coordinate is 0. On the unit circle, sine is the y value, and the y value is 0, so the sine of pi is 0. Number 10, the cosine of 7 pi over 4 is the same as the cosine of pi over 4, which is radical 2 over 2. Except that it might be negative depending on the quadrant. We know that pi is here. Since we have a denominator of 4, let's think of this as 4 pi over 4. 2 pi, which is over here, is 8 pi over 4. 7 pi over 4 is one multiple before 8 pi over 4. That means 7 pi over 4 will be right here in the fourth quadrant. On the unit circle, cosine is the x value, and x values are positive in the fourth quadrant because we are to the right of the y-axis. So we will simply leave the answer as positive radical 2 over 2. Number 11. The sine of 2 pi over 3 is the same as the sine of pi over 3, which is radical 3 over 2, except it might be negative depending on the quadrant. We know that pi is right here, and since we have a denominator of 3, let's think of it as 3 pi over 3. Therefore, 2 pi over 3 will be one multiple before 3 pi over 3. That puts it right here in the second quadrant. On the unit circle, sine is the y value, and y values are positive in the second quadrant, so we will leave the answer as positive radical 3 over 2. 2 pi is one of these angles that lands right on the lines. We know that pi is on the left and 2 pi is right here on the right. When we land on the lines, we use coordinates. So this is the unit circle. So we are 1 unit to the right, so the x-coordinate is 1. Because we are right on the x-axis, the y value is 0. On the unit circle, cosine is the x value, and in this case the x value is 1. So the cosine of 2 pi is 1. By the way, I'm drawing all of these pictures for instructional purposes. I'm hoping that you will get so comfortable with this process that everything I'm doing you can do in your head. You won't have to draw these pictures, and you won't need the chart. It will all be in your head ultimately. Having said that, if you need to draw a picture or draw a chart, do it. The sine of 5 pi over 4 will be the same as the sine of pi over 4. Just for fun, I'm going to put 1 over radical 2 this time. These are equivalent. Except it might be negative depending on the quadrant. Pi is right here. Because of the denominator of 4, we're going to think of it as 4 pi over 4. That makes it easy to see that 5 pi over 4 is one multiple past this. So that puts 5 pi over 4 right here in the third quadrant. On the unit circle, sine is the y value, and y values are negative in the third quadrant. So the answer will be negative 1 over radical 2. Number 14. The cosine of 5 pi over 3 will be the same as the cosine of pi over 3, which is 1/2. Except it might be negative depending on the quadrant. We know that pi is right here. With a denominator of 3, let's think of this as 3 pi over 3. 2 pi will be double this. That's 6 pi over 3. Therefore, 5 pi over 3 will be one multiple before 6 pi over 3. That puts it in the fourth quadrant. On the unit circle, cosine is the x value. X values are positive in the fourth quadrant. We are to the right of the y-axis. So we will leave the answer as positive 1/2. 0 is right here. It's the starting point. We are on the line, so we are going to use coordinates. This is the unit circle with a radius of 1. Therefore, the x-coordinate is 1. We are 1 to the right. The y-coordinate is 0. On the unit circle, sine is the y value. So, the y value here is 0. Therefore, the sine of 0 is 0. Number 16. The cosine of 11 pi over 6 will be the same as the cosine of pi over 6, which is radical 3 over 2. Except it might be negative depending on the quadrant. Pi is right here. Because of the denominator of 6, let's think of it as 6 pi over 6. We can think of 2 pi as 12 pi over 6. 11 pi over 6 is one multiple before 12 pi over 6. That puts 11 pi over 6 right here in the fourth quadrant. On the unit circle, cosine is the x value. X values are positive in the fourth quadrant. We are to the right of the y-axis. Therefore, we can just leave the answer as positive radical 3 over 2. Number 17. Earlier I mentioned that pi over 2 is right here at the top. You should just have that memorized. And because we are on the line, we will use coordinates. The x-coordinate is 0 because we are right on the y-axis, and the y-coordinate is 1 because this is the unit circle, radius of 1. We are up 1. On the unit circle, sine is the y value. The y value is 1. Therefore, the sine of pi over 2 is equal to 1. Cosine of 0. Well, 0 is right here on the unit circle. We will use coordinates because we're right on the line. and the x value is 1. We are over 1 to the right. The y value is 0. On the unit circle, cosine is the x value. The x value is 1, so the cosine of 0 is 1. The sine of 3 pi over 4 will be the same as the sine of pi over 4, which is radical 2 over 2. Except it might be negative depending on the quadrant. Pi is right here. With a denominator of 4, we will think of this as 4 pi over 4. So 3 pi over 4 is one multiple before this. 3 pi over 4 will be right here in the second quadrant. On the unit circle, sine is the y value, and y values are positive in the second quadrant. We are above the x-axis. So we can leave the answer as positive radical 2 over 2. And finally, the sine of pi over 6 is right here on the chart. That's 1/2. That was the end of the worksheet, but before I end this video, I want to take a moment to show you where these memorized values are coming from. The pi over 6 values and the pi over 3 values are related to an equilateral triangle. In geometry class, we did everything in degrees, and you learned that a triangle has a sum of 180 degrees. So, if you take an equilateral triangle where each of the angles are equal, you can find each angle by dividing 180 by 3. 180 divided by 3 is 60 degrees, so each angle was 60. Converting over to radians, 60 degrees is the same as pi over 3 radians. So the next time you see an equilateral triangle, I want you to automatically know that each angle is pi over 3. Here's an equilateral triangle drawn on the unit circle. Because this is a unit circle, the radius is 1. So this side of the triangle has a length of 1, and this side of a triangle has a length of 1. This whole side of the triangle has a length of 1, but that means that the part above the x-axis has a length of 1/2, and the part below the x-axis also has a length of 1/2. As we mentioned earlier, each of these three angles has a radian measure of pi over 3. So we have a pi over 3 in this corner, we have a pi over 3 in this corner, and this angle right here is also pi over 3. But it is being split right down the middle. Half of pi over 3 is pi over 6. So this piece is pi over 6, and so is this piece. My goal is to find the coordinates of this point. We already have found the y value of this point because it is up 1/2. So the y coordinate is 1/2. But what is the x coordinate? Well, that's going to be the length of this part of the triangle, which we have not found yet. Let's call it n. Let's call it x because we're looking for an x value. We can use the Pythagorean theorem to find this x value. So we know that this is a right triangle. So we know that leg squared plus leg squared is equal to hypotenuse squared. So x squared plus 1/2 squared will equal the hypotenuse squared, which is 1 squared. So x squared plus squaring the numerator and the denominator gives us 1/4, and 1 squared is 1. Subtracting 1/4 from both sides, so we have x squared is equal to 1 minus 1/4 is 3/4. So we have 3/4. And then we take the square root of both sides. So x is equal to, and normally we would say plus or minus, but this is a length, we're just going to call it positive. Positive square root of 3 over 4. when you take the square root of a fraction, you take the square root of the numerator and the denominator separately. So we have the radical 3, but the square root of 4 is 2. So check it out. The x-coordinate is radical 3 over 2. Okay, on the unit circle, we know that the x value is cosine. So the angle is pi over 6. So that tells us that the cosine of pi over 6 is radical 3 over 2. The y value is sine on the unit circle. So the sine of pi over 6 is 1/2. So cosine of pi over 6 is radical 3 over 2. When you look on the chart and you see cosine of pi over 6 is radical 3 over 2, that's where it came from. The sine of pi over 6 is 1/2. That's where this value on the chart comes from. The sine of pi over 6 is 1/2. In another video, I will show you where the pi over 4 values come from. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.